So let's start with the next session. First talk is by A.K.Mitra from the BARC Atomic Research Center on Einsteinian revolution misinterpreted.
Good morning, everybody. First, I would like to thank the organizers. So initially, I was hesitant whether to come so far away, but I found them very keen, very helpful, and very professional attitude. So I decided that I must come. And having come here, so I am enjoying this conference, and particularly after previous night's live concert, this has turned out to be one of the very best conferences in my very long professional life. I have given most of the things. I find that most of the people here are particle physicists, so it will be difficult for them to appreciate what I tell. So in such cases, they can always find most of the papers and supporting materials in these my websites, and some of it can be found in an easier term in my blog also, which is mostly based on my work. So general relativity is considered one of the most important intellectual revolutions ever happened. In fact, Chandrasekhar has described it as the most beautiful theory. And the basic concept, such a profound theory, came out of very simple ideas. That if you are in a free-falling elevator, you feel weightless, which means gravity can be locally transformed away, and locally you have special relativity. Then Einstein noted another thing, that electromagnetic interaction you can shield, but gravity you can never shield. So it occurred to his mind that this is something very fundamental. And after a long research, he came to the conclusion it must be associated with something very fundamental, the space-time geometry. So, but before that, we had Newtonian theory of gravity, which was also very nice theory. Here, you can have two forms. You can conceive of 2 point particles, and then you have a gravitational theory. You also have, in the Poissonian form, the continuous matter distribution is there with density rho, then also Newtonian theory works. In contrast, in Einstein theory, it is this kind of form. The right side you have matter energy momentum tensor, which is something like electromagnetic energy momentum tensor. So it is all kinds of densities, and this side is space-time structure, which comprises these metric coefficients. What are the metric coefficients? You all know, many particle physicists know the simplest thing, special relativity. This is the metric, the infinitesimal distance between space-time elements. In this case, metric coefficients are 1, 1, 1, and this is just square. This is a metric coefficient. This is considered flat. There is no gravity. But if something appears here, something non-trivial, non-constant, then maybe there is a gravity or some kind of acceleration. It has passed many experimental tests, general relativity. A strong gravity test it may not have passed, but it has never failed any test. But there are problems with some conceptual things like localization of global energy. So people are trying to solve the simplest of the problem. It started in Germany. It is called Massenpunkt in German. Massenpunkt, that is a neutral point mass. So and the present solution, actually whatever is known as Schwarzschild solution, was originally due to Hilbert, and it has this kind of form. So it is not correct to say that the Schwarzschild solution does not correspond to a point mass. It started with that thing, solution of a point mass. So alpha naught was the integration constant, this is integration constant, and this is the surface area on a unit sphere. So there is a Kressmann scalar, and the Kressmann scalar apparently is finite even at the event horizon. So apparently show that formation of singularity is inevitable in gravitational coulombs. I can go beyond this Schwarzschild radius and get inside. But I would maintain that this inside region is not physical space. So I feel that the space inside R is inside Schwarzschild radius must belong to a different universe and should not be taken into any physical theory. But black hole theory does take it into consideration. Black hole theory does consider it as a real thing. Then there is famous relativist Padmanabhan, who is one of the scientific organizers, I think, international committee. Now, in 1986, 89, he wrote a paper in physics lectures. He showed you take a box and self-gravitating perfect gas, and then count the number of states, statistical number of states. Then he showed that things are fine as long as the system size of the box is greater than 2m. But if the radius is 2m, then things blow up. It becomes infinity. Not only that, below that, number of states become negative. So he argued in this paper that actually this could be a physical singularity. It cannot be hand waving. You cannot say that this is a mere coordinate singularity. And in 2000, these two papers, I showed that if a point particle is coming, say test particle is coming towards the event horizon, by definition, for a massive particle, the world line is called time-like. But it would turn to null, that is, it would behave like a photon trajectory. Physically, this means that velocity becomes speed of light in violation of general theory of relativity. When you say velocity, people say, no, velocity can be another coordinate, other coordinate. But what I showed that dA square, which is the scalar, the metric, and dA square becomes light-like. So these two papers, and after this, many people got awake, and they started thinking of black holes could be something else, and there could be alternative black holes. Many thinking came after only these two papers. So what happens, then I showed, and this is one of the papers has been done from here also. This is from this lab, Logunov, and they have wrote a paper, they have written a paper in 2010. They have shown that velocity becomes light velocity for all kinds of black holes. Not only Schwarzschild black hole, Quark black hole, whatever black hole you tell. So these unphysical things happens which is not allowed by general relativity. So black holes must not occur. And then I showed actually based on other work that you take a point particle and calculate acceleration now do the scalar. In relativity we say scalars, they are important. The scalar, the acceleration has this kind of form. This is the Newtonian form. Black hole candidates are always sometimes solar wind kind of thing, ejection is there. That is why you can see electron-positron pair lines and many other lines, because they are solar wind type of thing is coming from them, plasma, and also solar flare kind of thing, coronal mass ejection kind of thing was coming. So that is why black hole, these candidates are much more violent than neutron star candidate. Sir, you are right. There are no true black holes got misled by the Hilbert solution of Masson-Punkt. We had no idea of Eddington luminosity, which many astrophysicists do not have, no string theorists, and no quantum gravitists have idea. The Eddington luminosity attained, then you can have hot quasi-static objects of ultra quasi-static plasma. Thank you.